Welcome to the wonderful world of elasticity. Part 5. Other measures of elasticity besides price elasticity of demand. So we might worry about other types of sensitivity. For instance, the sensitivity of demand for one product when the price of a different product changes. That's called cross-price elasticity. Or we might care about how consumers respond to income changes in their quantity demanded. That's income elasticity of demand. And finally, especially for producers, we might care about how much supply changes in response to price changes. So let's get started. The cross-price elasticity of demand measures how sensitive the quantity demanded of good A is to the price of good B. For instance, percent change in Q sub A over percent change in B, that's your cross-price elasticity. Now, in practice, what does this look like? It can help us figure out if goods are related. For instance, if they're substitutes or complements. For substitutes, if the increase in price in one engenders an increase in demand for the other, it's likely that the two goods are substitutes. If the price of the cookies on the left rises and you in turn buy more of the round cookies on the right, it probably means that you consider them to be substitutes. And so the percent change in price on the left is positive, and the percent change in quantity demanded on the right, positive as well, pardon me. And that means you have a positive sign on your elasticity. For complements, it's going to be the reverse. Cross-price elasticity of demand coefficient is negative for these guys. So an increase in the price of milk causes a decrease in the demand for Oreos. Let's check in on a question. I'll read it. You can pause it, work the problem, and then I'll share the answer. The price of good B increases by 4%, causing the quantity demanded of good A to decrease by 6%. The cross-price elasticity of demand is what, and the goods are what? So there's two things to think about here. One is calculating the coefficient, and the other is the sign of the coefficient. Go ahead and pause and work the problem, and then we'll share the answer. Okay, you should have got a negative 1.5 because the quantity demanded goes on the top, price goes on the bottom. So percent change quantity demanded of A is 6%. Percent change of price for good B goes on the bottom, and that's a positive price, and on the bottom it's a negative quantity change. So it's a negative sign, and it's 6% over 4%, you get 1.5. The income elasticity of demand measures our income and how sensitive our demand is to our income. So percent change in quantity demanded goes on the top, percent change in income on the bottom. So are you starting to feel like all these equations are almost the same? It's true. It's always percent change on top in a variable, usually quantity demanded, and then the percent change in income or price or the price of the other good goes on the bottom. It's all relative elasticity, relative changes in price versus quantity or income versus quantity, etc. So it's basically just a pattern. All right, so income elasticity of demand can be used to distinguish normal from inferior goods. And as a reminder, a normal good is one which you consume more of when your income rises and less of when your income falls. And inferior goods are the opposite. So for instance, if fast food is an inferior good, and as economists we believe that it is, one of the reasons why obesity is concentrated in low incomes, probably you'll have an increase in fast food if you lose your job or hit a low patch and your income drops. So normal goods are positive for their income elasticity, and they can be very positive or slightly positive. So vacations are positive, right? They're a normal good. Income rises, people take more vacations if they can. They take a lot more or a little more. Well, think about it in reverse. When your income falls, you take a lot less vacations. So we would say that it's a pretty elastic good. It's still a luxury good. But for income inelastic goods, if your income rises by 30% and you only consume 4% more whole wheat flour, for instance, we would say it's a positive good, or it's a normal good, but it's not, you're not very sensitive. So one of the problems over time is that, for instance, in the farm industry, incomes in the US have risen substantially over the last 100 years, let's say. But people's incomes may rise by 100% over time, but they're not going to buy 100% more agricultural products. So here's a practice good. Tanya consumes 10 boxes of ramen noodles a year when her yearly income is $40,000. Let's just say she's eating other stuff as well, obviously. But after her income falls to $30,000, she consumes 40 boxes of ramen noodles a year. So her income dropped and she's consuming more. Calculate her income elasticity of demand for ramen noodles. I'll pause here. You can work the problem, then I'll share the answer. Okay, so right away you should have noticed that it's a negative sign, and as her quantity demanded of ramen rises, as her income drops. And how much? You would go through the whole calculation of figuring out what the percent change of 10 to 40 is, and the percent change of 40 to 30 is. And you'd want to use the midpoint formula again. So last but certainly not least, the price elasticity of supply. So usually we know that supply curve slopes upwards. Sellers offer more when prices are higher, but how strong exactly is the relationship? So the setup is very similar to all the other elasticities. We've got price elasticity of supply being the percent change in quantity supplied this time divided by the percent change in price. And to look at some extremes here, let's say if there's only a certain number of cell phone frequencies, radio frequencies, whatever you call these things out there, even if the price were to rise, there is simply no way to create more of this good. Other examples of perfectly inelastic supplies where the quantity does not change regardless of how much price changes are like art by Picasso. Things that take a really long time to build up the production for instance, nuclear power plants. The price of electricity could rise today by 40%, and it's going to be a while for a nuclear power plant to come online, probably decades. So in the short run, they can't really respond. And there's a lot of agricultural industry this way. You can't magically create more cattle out of thin air or more almond trees out of thin air. So we do think about the elasticity of supply, especially in the short run versus the long run. A perfectly elastic supply curve would be one where it's flat and, again, very rare, but just to sort of look at the opposite extreme, the price of pizza is $12. Producers will supply any quantity and any other price, they won't produce that necessarily, especially a price that's lower. This gets a little bit more into the weeds about costs and firm behavior, which we'll talk about in another video. But basically, you want to think about the steeper supply curve being the less elastic and the flatter supply curve being more elastic. It's not, again, a reminder that elasticity is not exactly the same as slope, but they are related. Here's an inelastic supply curve, or relatively inelastic, at least when you compare it to a flatter, more elastic supply curve. How do we characterize supply curves? A supply curve, we call it relatively elastic if the numerator is above the denominator, and basically if it's above 1. So if the price rises a little bit and the quantity supplied, or percent change in quantity supplied on top changes a lot, we would call that elastic. And inelastic if it's the price change doesn't cause much of a difference in quantity supplied. Again, it's that idea of rubber bands, right? Inelastic would be not very stretchy, not very responsive. Elastic is very responsive. So what are the things that factor in if we're wanting to think about production and understand firms' decisions here? How fast can firms get a production level increased? If there's a limited amount of inputs, for instance, rare earth minerals are hard to get, or they're controlled by one or two countries, or the feed for your cattle is you can't secure an increase in the supply, you're going to have very expensive and hard path forward to increase your production. So you'll find those supply curves to be relatively inelastic. This is sort of a sad example here, but some hope in the future. Ivory, coming from elephant tusks, is pretty inelastic supply, right? It's very difficult, expensive, illegal, and just downright bad to be doing this. So the supply curve for ivory is going to be fairly inelastic. And then another factor is time. We've already sort of mentioned this, but the more time you give anybody, consumers, or in this case, producers, to adjust to a price change, the more they will. So for most goods, nuclear power plants, etc., almond farmers, you're going to get a long-run price elasticity of supply that's higher. They can sort of respond better to price changes over time. Give them time to plant trees, to plant nuclear reactors, and you're going to see that they will respond more over time. Price rises, they can't do much now, but in the future they may just increase by 30, 40, 50%. So here's a quick question. I will read it. You can pause it and run the problem if you like, and then I'll share the answer. Which supply curve is the most elastic? S1, which is the steepest, S2, slightly less steep, S3, a little bit flatter, S4, almost totally flat. And the answer is the flat supply curve is the most elastic.